Morning, dear students. How are you today? I hope you're fine. Today we're going to have the second lesson on chapter 3, simplifying algebraic expressions. What you will learn by the end of this lesson, you're gonna be able to use the distributive property to simplify algebraic expressions. Okay, we have some vocab, term, coefficient, like terms, constant, simplest form, simplifying, and expression. Okay, can you use the algebra tiles to algebraic expression? Let's see. You can use algebraic tiles to represent expressions. You can also sort algebra tiles by their shapes and group them. As you see here, the drawing on the left represents the expression. The drawing here represents the expression. Okay, the marker. Okay, I have here 2x plus, as you see here, 3 plus 3x plus 1. Okay, so I have here what? Can you see it by your own eyes? I have here 5x, the green one, 5x, the green ones. And I have here how many yellow? 1, 2, 3, 4. So I have here 4. So it will be 5x plus 4 by your own eyes. It's easy. There are 5x tiles and there are 4 1 tiles. Okay. So therefore 2x plus 3 plus 3x plus 1 gives you 5x plus 4. Okay, my dear students, let's see this. Model each expression. This is for practice. Model each expression A, B, C, D by yourself. Simplify expressions. When plus or minus signs separate an algebraic expressions into parts, each part is a term. Each part is a term. The numerical part of a term that contains a variable is called the coefficient. It's called what? The coefficient. The coefficient of the variable. So I need the marker here. As you see here, this expression has 4 terms. How many terms here? 1, 2, 3, 4. Each one here is called term. Is it important to know the definitions and the expressions here? Yeah, you have to know all the names of any term of the expression here. 2 is the coefficient of 2x. Here you have 2 is the coefficient of 2x. I have here 1 is the coefficient of x. As you see, it's invisible because x equals 1x. Okay, like terms, focus here. Like terms, focus. Like terms are terms that contain the same variables. Okay, when I say focus, so this is something very important. So like terms here are terms that contain the same variables, such as 2n and 5n, such as 2n and 5n, or 6xy, 4xy. A term without a variable is called constant. Constant terms are also like terms. So 3 here is a constant, but here 5y it's a variable, right? Okay, my dear students, rewriting a subtraction expression using addition will help you identify terms of an expression. Identifying parts of expressions. Identify the terms, like terms, coefficients, and constants in the expressions. Example 1. Okay, I have here I have here this example: 3x minus 4y plus y minus 2. What should we do? I have here 3x plus 4x, as you see, plus y minus 2. What are the like terms? I have here 3x, 4x. 3x minus 4x, my dear students, don't forget to put here plus 3x plus and open a bracket, then negative 4, and then complete your answer. Why? Because I want to solve for this. When I say 3x plus negative 4x, so the answer will be what? Yes, I can hear you. 1 negative x. Why? 4 minus 3 equal 1, as you see. And I here took the sign of the greater number, which is here negative. So negative x. I have here plus 1y, y means 1y. Okay, plus negative 2. So this is the definition of subtraction. We write this is the definition of subtraction. Identity property. Here this is the identity property. Okay, 1y here, identity property, 1y. Okay, then the terms are 3x and negative 4x, as I told you. So I have here the remainder is negative, yes, negative 1x. This is means negative x. And I have here y and negative 2. The like terms, as I told you, 3x and negative 4x. The coefficients here I have 3, negative 4, and 1. The constant is what? The constant is only negative 2 without any letters or any variables, as you see. Okay, an algebraic expression is in simplest form if it has no like terms and no parentheses. When you use the distributive property to combine like terms, you are simplifying the expression. So, as you see here in example 2, simplify algebraic expressions. Okay. So, how to simplify the algebraic expressions? 2x plus 8x, we have here the same, yes, they are like terms. 2 plus 8 gives me 10x. Okay, what's done here? Okay, I will tell you. 2x plus 8x are like terms. It's written like this. Okay, the marker again, 2x plus 8x. So I used the distributive property. I put the x outside and I added 2 plus 8, gave me here 10x. Okay, simplify. Also here I have here 6n plus 3 plus 2n. 6n and 2n are like terms. So I have here 6n plus 2n. I changed the places, so it's what? Commutative property. Excellent. Okay, I can hear you. And I have here grouping. I will group here, put into the brackets 6 plus 2 and n outside. This is called what? Distributive property. Okay, so 6 plus 2, 8, n plus 3, and this is simplifying. And another one here I have 3x minus 5 minus 8x plus 6. It's easy now. Yes, it's easy. 3x and 8 negative 8x are like terms. Okay, with x's. Negative 5 and 6 are also like terms. Negative 5 and 6 are like terms, and I know that they are constants. So I have here 3x plus negative 5. Here, what did I do? Subtraction. Definition of subtraction. And here then 3x plus 8 plus negative 8x plus negative 5 plus 6. Commutative property, I changed the places or the order of numbers. And then distributive property, I put here x outside and here 3 plus negative 8, and then solve for this. Negative 8 plus 3, it gives you negative 5x. And I have, and because x is outside, I have here negative 8 and 3, negative 5, and then x plus what? 6 and negative 5 gives me 1, positive 1. It's very interesting. I have here m plus 3, all bracket n plus 4m. What should I do here? I have here m plus, okay, so I have here to do what? Need the marker? Yes, I have here m, okay, as you see, m plus 3n, then what? Then 3 times 4m. This is distributive property. Here m and then 3n, and here 3 times 4, 12m. This is what? This is associative property. Associative property to solve here the brackets. And here 1m. Okay, why did I write here 1? Because here when I say m alone, it means that it has 1 invisible. So 1m plus 12m, as you see. Okay, 1m plus 12m. This one here, I bring it here, I brought it here, then plus 3n. When I change the places, commutative property, right? Then I put m outside. 1 plus 12 gives me 13m plus what? Plus 3n. Simplify. It's very interesting to do so. Okay, example 3, translate verbal phrases into expressions. Baseball cards. Suppose you and your brother collect baseball cards. He has 15 more cards in his collection than you have. Okay, he has 15 more. So write an expression in its simplest form that represents the total number of cards in both collections. Okay, on the word here, you have some cards. Your brother has 15 more. This is the words that I can say. I have some cards. I don't know how much, but my brother, how many? But my brother has 15 more than me. Okay, let the number that's unknown is, let's be x, number of cards that you have, and unknown. X plus 15 gives me the number of cards of my brother. So to find the total, add the expressions I have here. X plus the total, and he asked me to find the total. X plus x here, the number of cards I have, and x plus 15 of my brother. X plus 15 gives me what? Okay, so here, okay, want to erase this to make it more clear. So here I have x plus 15. So what did I do? I changed it. Okay, I regrouped here, make associative property, and then what's this? 1x plus 1x, okay, identity property, and then put the x outside, and this is called distributive property, and then simplified. 1 plus 1 equal to x plus 15 simplified. Okay. By that, we have covered the lesson. Study well from the YouTube presentation and go back to the practice book and solve this practice lesson. Okay, and if you have any problem, send me on Google Classroom. Thank you, my dear students.